Let's look at this problem where we've been asked to graph the parabola given by the equation y equals x minus 1 squared minus 4. This equation has been given to us in vertex form. The general form for a parabola that's easily graphed is y equals a times x minus h squared plus k. So you can see that our equation matches that form, where our h is 1, and k is negative 4, and a is also 1. If you don't see a number there, then that means that it's 1. You can put it in if you want to. So the first thing you can pull out of this is the actual vertex of the parabola, which is the point where it turns around. And the vertex is always located at the ordered pair h, k. Okay? And in this case, we said that h is 1 and k is negative 4. Notice what happens with the signs here. Although there's a minus sign in front of the 1 in our original equation, we still only take h as positive 1. That's because the formula says that it's negative h, or the opposite of h, that's going to be the location of the vertex. So whatever number you see inside here, if it's a negative 1, that means your vertex is going to actually have a positive 1 for its x-coordinate. If this had been a positive number, then this would be a negative. So take the opposite sign of this number when you're finding the x-coordinate. But for k, since it's built in as keeping the sign of k plus k, that means that whatever sign is in front of the 4, or the number, you keep it on there when you're finding the y-coordinate of the vertex. Okay, so opposite of this number, keep the sign on this number, which means that our vertex is at 1, negative 4. What you can do is you can plot that right onto your graph paper. Okay, oops, let me just fix that up a little bit. Sorry, touchy screen. Okay, pretty good. We also know from the original formula that the a number, whatever it is in front of here, determines if the parabola opens up or down. And that is determined by if it's positive or if it's negative. So if a is positive, like in our case, it's a positive 1, that means that the parabola is going to open upwards. Okay. If it happened to be a negative number for a, then we would say that the parabola would open down, which looks like this. The value of a will also help determine if the parabola is wide, like that one, or if it's going to be more skinny, like this one. So we can't draw the parabola in yet unless we get some more information. And one of the easiest things to find is the Y-intercepts. So let's go ahead now, make some space here, and see if we can figure out where this parabola crosses through the y-axis. So we know it opens up from here. So it could open up skinny, or it could open up wide. We don't know yet. So in order to figure out where it crosses the y-axis, let's put in x equals 0. So to find the y-intercept, I'm going to put in x equals 0 into the equation and see what you get. So we get y equals 0 minus 1 squared minus 4. And if you calculate that out, you get 1 minus 4, which is negative 3. So now we know that we can plot the y-intercept at negative 3 on the y-axis. Okay. Well, the other thing that we know in order to get this more accurately is that parabolas are symmetric. So however wide it opens in this direction, it's gonna, from this vertex, it's gonna open the same width in the other direction. It's symmetric about the vertex. We call that the axis of symmetry, which would be like a line, if you can imagine it, that goes vertically through the vertex. Okay, so let me see if I can just sketch one in. Oops, a little bit too far over. See, so I drew a vertical line in there that goes through the vertex, and you can think of it as like a mirror. And so however wide this thing opens up on the left side, it's going to do the same thing on the right side. So that dot that we plotted that was the y-intercept is 1 unit away to the left from this axis of symmetry. It's 1 unit to the left, right? So that means there's another point that this thing opens upwards that's going to be across from it 1 unit to the right. So if I put a dot right there, then I would have another point that I could plot and get more accuracy. You may be also asked for the x-intercepts. It depends on the problem. If you wanted to find the x-intercepts, what you can do is plug in y equals 0. So we'll do that as well, just in case you need to have all that information about the parabola. So to find the x-intercepts, we know it's going to be found if you plug in y equals 0. We know this is going to have some because it's opening upwards, so somewhere over here we think it's going to cross through the x-axis. We just have to figure out exactly where. So I plug in y equals 0 into the original equation. I get 0 equals x minus 1 squared minus 4. And the easiest way to solve this is actually the square root property. So watch what happens. If I add 4 to both sides, I get 4 equals x minus 1 squared. And then that's in the nice format that if I just take the square root of both sides, but I would put a plus or minus in front of the 4, then I can just bring this down as x minus 1 equals plus or minus 2, square root of 4. And then I'm going to add 1 to both sides. I'm going to go this way, which is going to give me x equals, and the stuff over here is 1 plus or minus 2. I'm going to put the 1 in front of the plus or minus 2, which calculates out 1 plus 2 is 3, or 1 minus 2 is negative 1. And those are the x-intercepts for this equation. So we can also plot them in and get a really nice picture of the parabola. We said one's at 3, and the other one's at negative 1. And so if I scoop through, remember it's kind of a U shape, these parabolas. It goes on forever, so put an arrow. I get a really nice picture of the parabola. One last thing, if you're asked to indicate what is the range of the parabola, range refers to how low or how high does the graph or the picture go. So you want to start with what's the lowest point on the graph. So if I go down, 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 there's as low as it goes. How low did it go? It went down to negative 4. So that would mean that the range starts at negative 4. And then how high does the parabola go? It goes up, 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 up. Oh, it goes up forever. So we use infinity to represent the top of the range. And we can put that in interval notation. From bottom to top, it goes from negative 4 inclusive to infinity. And you use a bracket on the negative 4 because that means that the parabola actually achieves that value. But you have to use a parentheses on the infinity because you can't achieve the value of infinity, which means it goes on forever. So this is what's called the interval notation for the range. And it's a nice notation when you're asked to find the range. Alright, I hope that covers it. Enjoy graphing parabolas.
Made with Doodlecast Pro.